Okay, so here's some more examples. Let's look at the first one and see what happens if I solve using the addition method by multiplying both sides of the first equation by -8 and writing that result below, sorry, by -2. -2x minus 4y equals -8. And now when I add both of these equations together, I get 0 equals 0. So when you were in beginning algebra, you would say, oh, infinite family of solutions. So now we're asking you to get a little bit more sophisticated and say that this is a consistent system of dependent equations. So in fact, when there are only two, it means one is a multiple of the other, and you can see that, I bet, if you look hard. So the way you write the solution in this case now is you say it's the set of all x, y ordered pairs such that, so the vertical line means such that x plus 2y equals 4, because that's the condition that has to be true in order to have a solution to this system of equations. So there's a lot of solutions. If y is 0, x is 4. So that's a solution to the system of equations. If y is 1, x is 2. So that's also a solution to the system of equations. And you could keep going forever. So we have an infinite family of solutions, but it's a very specific infinite family of all the points on this line. Okay, so let's look at the second example. I'm going to multiply the first equation by -3. Get -9x plus 3y equals -21. And I get, again, 0 equals 0. So this is also a consistent system of dependent equations. And I write the solution set as x comma y such that 3x minus y equals 7. So you can also write this by solving for the y and saying y equals 3x minus 7. And you can say the set of all x, y such that x is whatever you want and y is 3x minus 7. Where, comma, x is any real number you like. So this notation means x is any real number. So it says pick a real number, put that in the first slot, then do 3 times that and subtract 7, and that's what goes in the second slot, and then you'll have a winner. You'll have a point that is a solution to the system. Okay, so let's look at a few word problems. And we have a company making running shoes with a fixed cost of $300,000. So we're going to have a cost function where x is the number of pairs of running shoes. And so fixed costs happen even if you're not making any shoes. So it's 300,000 plus. So fixed cost is 300,000, and then this hashtag was surely supposed to be a dollar sign. And $30 for each pair of shoes, so 30x is going to be what are called the variable costs. So there's my cost function. That's part A. So then part B says write a revenue function for selling X pairs of shoes. So if I sell X pairs at $80 a pair, I'm going to get 80X as my revenue. So then it asks us to find the break-even point. So the break-even point is when cost equals revenue. Because if your costs, how much you're spending, equals your revenue, how much you're getting back, you're right at the break-even point, and you're hoping you're going to tilt towards the revenue getting bigger than the costs. So you can find that break-even point by setting these two equations equal to each other. So you're basically solving this system of equations by substitution, by saying this is when C equals R, what happens? And so you'll have 50x equals 300,000. And we have x is 6,000. So make sure in a word problem you say pairs of shoes. And it's not 6,000 shoes because it's pairs of shoes. Okay, so let's look at a mixture problem. And we have 15% alcohol and 40% alcohol. And we want to mix these together and end up with 30% alcohol. So if the number you want is closer to the 40, you'll need more of the 40 in order to end up closer to 40 as your result. So let's define some variables. Let's have x be gallons of 15% alcohol and y be gallons of 40% alcohol. So we're looking to have alcohol plus alcohol equals alcohol. So we're going to have 15% of the X amount, that's going to be the alcohol in the first bucket, plus 40% of the alcohol in the second bucket. Only 40% of that solution is alcohol. And I want to end up with 20 gallons of 30% alcohol. So this is alcohol plus alcohol equals alcohol. So this is one equation. Then my other equation is that I want 20 gallons. So x plus y has to equal 20. So many times these equations are easiest to use substitution method. So you could say y equals 20 minus x. And then put 20 minus x in here for the y. So we'd have 0.15x plus 0.40 times 20 minus x. And we want that to equal 6. And then I'm going to distribute here and solve for my x. So I'm going to have 0.15x plus 8 minus 0.4x equals 6. So it looks like 2 is going to equal 0.25x. Make sure and check me on that. And so x is going to equal 8 gallons of 15% alcohol. And then we know we wanted 20 gallons altogether. So y is going to be 12 gallons of 40% alcohol. So see how I needed more of the 40% to end up with a result that was closer to the 40%. Okay, I'm going to have one more example that's a really common word problem that goes with systems of equations. I have an airplane, it's going 600 miles. So the trip is 600 miles both ways. One way it's going with the wind. So you have the plane going and you have the wind helping. So if x equals the plane speed and y equals the wind speed, when you're going this direction, it seems like your speed is x plus y. So that's speed. So that has to equal speed, 600 miles in 4 hours. So distance over time, that's speed, right? That's rate. So that's my one equation. Then when I'm coming back the other way, the wind is still blowing this way, but now my plane is going this way. So my plane's speed is having the wind's speed subtracted. So that slows me down and it takes me 5 hours to go the 600 miles. Well, this is a really nice system of equations because I can just add the two equations here and the y is already going to cancel. So I'll get 2x is the 600 divided by 4, or 150, plus the 600 divided by 5, 120, and then divide both sides by 2, and get x is 135 miles per hour, and that's the plane's speed. And then I can use either one of these equations. So let me use the first one and say 135 plus y is 150. So the wind speed is 15 miles per hour. Pretty good wind. Okay, and that's all we have for this 3 sections.